Download this code from codegive.com, link in the description below. Domain-driven design, DDD, is a software development approach that focuses on modeling software to reflect the complexity of the business domain. One of the core concepts in DDD is the aggregate, which is a cluster of domain objects that can be treated as a single unit. In this tutorial, we'll explore how to master DDD aggregate modeling in 3 steps, accompanied by code examples in a hypothetical e-commerce scenario. Step 1. Understand the domain. Before creating aggregates, you need a deep understanding of the domain. This involves identifying the key entities and their relationships, as well as understanding business rules. Example domain, e-commerce. In our e-commerce domain, we will identify the following key entities. Order represents a customer order. Order item represents an item in an order. Customer represents a customer placing the order. Step 2. Define the aggregate root. An aggregate root is the main entity that controls access to the other entities within the aggregate. It ensures the consistency of changes within the aggregate boundary. Example, order aggregate. In our case, the order will be the aggregate root. It will manage order items and ensure that any changes to the order's items follow business rules. Here's a simple implementation in C#. Public class order item. Public GUID ID get, private set. Public string product ID get, private set. Public int quantity get, private set. Public order item, GUID ID, string product ID, int quantity. ID equals ID. Product ID equals product ID. Quantity equals quantity. Public class order. Public GUID ID get, private set. Public list order item items get, private set, equals new list order item. Public string customer ID get, private set. Public order, GUID ID, string customer ID. ID equals ID. Customer ID equals customer ID. Public void add item, string product ID, int quantity. / business rule, you can't add a negative quantity. If quantity equals 0. Throw new argument exception, quantity must be greater than 0. Var item equals new order item, GUID.new GUID, product ID, quantity. Items.add, item. Public void remove item, GUID item ID. Var item equals items.first or default, I equals I.id equals item ID. If item equals null. Throw new argument exception, item not found. Items.remove, item. Step 3, enforce invariance and business rules. The aggregate root is responsible for enforcing business rules and invariance. This means that any operation that modifies the aggregate must go through the aggregate root. Example, adding and removing items. In our order class, the add item and remove item methods enforce business rules. For example, we check that the quantity is positive when adding items and ensure that the item exists before removing it. Here's how you might use the order aggregate. Public class order service. Private read-only list order underscore orders equals new list order. Public order create order, string customer ID. Var order equals new order, GUID.new GUID, customer ID. Underscore orders.add, order. Return order. Public void add item to order, GUID order ID, string product ID, int quantity. Var order equals underscore orders.first or default, O equals O.id equals order ID. If order equals null. Throw new argument exception, order not found. Order.add item, product ID, quantity. Public void remove item from order, GUID order ID, GUID item ID. Var order equals underscore orders dot first or default, O equals O dot ID equals order ID. If, order equals null. Throw new argument exception, order not found. Order dot remove item, item ID. Conclusion. Mastering DDD aggregate modeling involves understanding the domain, defining the aggregate root, and enforcing business rules through the aggregate. In our e-commerce example, the order aggregate encapsulates the order item entities, ensuring that all modifications respect the defined invariants. Key takeaways. 1. Domain understanding, identify key entities and their relationships. 2. Aggregate definition, choose an aggregate root that encapsulates related entities. 3. Business rules enforcement, ensure that all changes to the aggregate follow the business rules. By following these steps, you can create robust domain models that reflect the complexities of your business domain, leading to more maintainable and understandable code bases.